Today we're going to talk about complex rational expressions. So there's two things we need to talk about before though we get started with that. So the first thing is implied parentheses. And so if we think about work that you did back in middle school, you would have done something like 3 plus 5 all divided by 7. And so here with this, we can't just take the 3 divided by 7 and the 5 divided by 7. Those go together. So there are implied parentheses that go around that 3 plus 5. That brings up the whole thing about order of operations. So we have to make sure that we're doing things in the correct order. Meaning if we're looking back at this simplified version of a complex rational, we would have to add the numerator first and then divide by the 7. Okay? So remember implied parentheses and order of operations. So let's take a look at our first example. So we have 1 plus x divided by y, all divided by 1 plus y divided by x. So complex rationals just mean that you just have a fraction within a fraction, okay? So that implied parentheses is telling us that we need to do everything in the numerator, then everything in the denominator, and last we have this big fraction bar. Okay, this big division bar. So, however you do this, you need to make sure that you're keeping yourself very organized with your work. So I'm going to separate it out. I'm going to say numerator, and I'm going to do my work here of taking 1 plus x over y. So I know that if I'm getting a common denominator between those, it would be y. So this is just 1 over 1. So to make that have the common denominator, we would multiply by y to both pieces. So we would get y, and the second fraction already has the common denominator. So we have y plus x over y. That's our numerator. We're going to leave it alone, okay? We're going to do the same thing to the denominator. We have 1 plus y divided by x. So our common denominator for those pieces would be x. And then again, this is 1 over 1. So to get the common denominator, we're going to multiply that fraction by x. The second fraction already has the common denominator, so we have y. So now what we have is our numerator is being divided by the denominator. Okay, now we have a division question. And with division, we're going to keep the first fraction the same. And then we're going to flip the second one to multiply. Now in this, remember we would also factor everything as much as possible, but there is nothing else for us to factor. So this y plus x and x plus y, those are binomials, so they can go in parentheses if you want them to. Y plus x, x plus y, those are allowed to cross off. And so we would be left with x divided by y. So that is our answer. All of this craziness back here in the beginning ends up just being x divided by y in the end. Now, because these questions get a little bit more complicated and messy, we're not going to worry about restrictions for these. So you just have to work on simplifying them, okay? So let's take a look at one more. So we have a divided by b minus b divided by a, all divided by a divided by b plus 2 plus b divided by a. So again, you're taking things in pieces. There are implied parentheses that you should be doing everything in the numerator first, everything in the denominator second, and then working on the division. So you don't have to show your work the way I am to make a common denominator. Some people kind of draw arrows off to the sides and deal with it that way. It's kind of up to you. Just keep track of it, okay? Keep it organized. So we have subtraction, so I'm going to make that b plus a negative so I don't forget about it. And if we have a divided by b plus negative b divided by a, our common denominator there would be ab. So the first fraction has the b. That means we're going to multiply it by a and get a squared. The second fraction is missing the b, so we're going to multiply that numerator or that fraction by b and get minus b squared. We're going to leave that alone for right now. Same thing with the denominator. So here We're getting a common denominator between all three of these pieces, which would be a, b. The first fraction is missing the a, so it's going to give us a squared. The second fraction is missing the a and the b, so that would become plus 2ab. And then the third fraction is missing the b, so that's going to be plus b squared. Okay, so you must do those things first. Now we have a division question. Now we're dealing with this division bar. So we have our numerator divided by our denominator. And for division, we need to factor everything as much as possible, and then we flip the second fraction to start crossing things off. So let's factor kind of as we go here. A squared minus b squared is the difference of squares, so we get a plus b, a minus b, over ab. The second fraction we're going to flip, so this ab is going to move to the top, and then a squared plus 2ab plus b squared can factor into a plus b and a plus b, or you could also say a plus b squared, doesn't matter. Okay, so now we're going to work on crossing things off. A plus b is the same thing as a plus b. These are monomials, so that monomial a can cross off of that monomial a. Same thing, those b's are both monomials, so anything divided by itself is just 1. Now, a minus b divided by a plus b, are those two the same thing? So 3 minus 2 is not the same thing as 3 plus 2. So those two things do not cross off, which means that our answer would be a minus b over a plus b. And that's it.